Hi, folks. Welcome to 3.3 Power Functions and Polynomials. And so we're going to get started here today with our what we know and what's new. All right. So what do we know so far? Well, we know a few different graphs, right? We know f of x equals x is a linear function. We know that f of x equals the absolute value of x is more like a V shape. We know that f of x equals x squared is our parabola, or more of a U shape. We know that the square root of x is sort of something like this, right? It has a restricted domain. That's sort of the first time we've seen the restricted domain. And lastly, we know that f of x equals x cubed looks something like this, okay? And so we have some that have restricted domain issues, and we have some that have restricted ranges, right? Our absolute value of x can't have a negative number come out, and x squared can have 0 come out like the absolute value, but not anything negative either, okay? All right, oops. So let's talk about what's new here. All right, so what's new on our plate today? We are going to take a look at some new types of functions, all right? In particular, we're going to be looking at power functions and then polynomial functions. And our next few sections, actually, so 3.3 all the way to 3.6, all talk about polynomial functions. It's a very special family of functions that we use quite often. All right, so let's jump into this first part where we distinguish between power functions and polynomial functions, right? So it turns out that a power function is something of this form. F of x equals kx to the p, all right? And here's what these letters mean, okay? K is a coefficient. It just means it's a number in front of the x to the p. It could be 1, all right? It could be 2, it could be a half, doesn't really matter. But p is the power of our power function, okay? And it can be any real number, right? What that means is it could be 1, 2, 3, all these whole numbers, but it could also be -4, -7, it could be 1/2, it could be -3/5, right? All of these are real numbers, so they could all be powers in our power function, okay? But one key thing to note here is that we only have one term in a power function. Okay, so there's only one term in our power function. One term allowed. Now, in contrast, let's look at what it means to be a polynomial function, okay? And we're going to write a general form here. F of x equals a to the n x to the n plus a to the n minus 1 x to the n minus 1 plus, and we're adding a bunch of terms until we get a2 x squared plus a1 x1 plus a0, okay? Now, any of these a's with the little subscripts here, right, all of these, a sub n are coefficients. Just like in the previous one, the power functions, it's just like our k, right? Except if we have more than one term, we can have more than one coefficient, right? And instead of p being the power, we actually have n is the power, okay? N is the power, but we have some restrictions on what n can be, all right? It can only be non-negative integers. All right. So we can have 1, 2, 3, 0 is okay also, but like -2, -3, -5, those would all be bad because they're not non-negative, right? So we wouldn't include those. And we couldn't have any of those fractions either because these are not integers. Okay, so we can have powers, but we can only have different kinds of powers, right? And one last thing here, instead of only one term allowed, we can have multiple terms are allowed. Okay. All right, so we've got some similarities between them. We have some coefficients, we have some powers, but in the power function, you can have any real number be your power, but in a polynomial, you're limited to only certain numbers. We can't have the other numbers. And last difference, power functions have one term only, and polynomial functions can have multiple terms, all right? So let's take a look at these 4 examples. And the directions say determine whether the given function is a power function, a polynomial function, both, or neither. All right, let's start with example 1. So first thing I do, I go ahead and I look through. I notice that I have a bunch of powers. Okay, and none of these powers are the same. 5, 3, and 1. They're not the same. So I can't combine any of these terms here. They're all different kind of terms, right? And I notice that I have not just 1, but 3 terms, okay? So this one could be a polynomial, right? But it is not a power function because there's more than one term, okay? All right, let's take a look at example 2 down here. G of x equals 2x squared times 4x cubed. Now this is a multiplication, so I'm able to actually combine these terms. So 2 times 4 gives me 8, and x squared times x cubed actually gives me x to the 5th, because I have 5 of the x's multiplied together. Now that I've simplified this, this could be a polynomial because this power 5 is a non-negative integer. Okay, so it is a polynomial. It's only got one term, but that's okay. It is also a power function because it only has one term and the power is a real number. Okay, so in this case, example 2, we actually have a function that is both a polynomial and a power function. All right, let's take a look at example 3 over here. So example 3, we have h of x equals 2x to the 5th minus 1 over 3x squared plus 4. Now, what I see here is this fraction line. And this fraction line tells me that what I have here is actually called a rational function. And we're going to take a look at that later on in a few days. Okay, this is a rational function. It is not a polynomial because I'm dividing here. Okay, and it is not a power function because I have more than one term on the top and on the bottom. So this one, example 3, we would say is neither. It's not a polynomial or a power function. All right, last example here, k of x equals the square root of x plus 3x squared. And one thing that I've been hinting at is this square root of x can actually be written as x to the 1/2, and then the 3x squared stays the same, okay? Now, I see more than one term here. I see two terms, so I automatically know that I don't have a power function because there's more than one term, and I can't combine them. Is it a polynomial? Well, 2 is a non-negative integer, but, oh, shoot, I got a 1/2. That is not an integer. So this is also neither a power function or a polynomial, all right? Now, if I change this 1/2 to be a 5 or an 8, then it would be okay. It would be a polynomial, all right? But as soon as I see the fraction, no go on the polynomial. All right, folks, let me zoom out so we can get this whole page on one screen real quick for you. But that is our 3.3 part 1. Come on back here for part 2.